The ancient Egyptian civilization was a powerful society and was known for the creation of its many innovative systems. The Egyptian numeral system was one of these, which was created around 3300 BCE. Specific characteristics of this numeral system was using hieroglyphic images. The system was used mainly in areas of centralized government for recording taxes, accounting, and even in religious institutions. The system was developed to solve the practical problems, but it wasn't commonly used by most of the population. It is also known as the first base 10 numeral system, which allowed for the representation of large and small numbers.
So with this slide, the additive nature of Egyptian numerals, the value of a number is determined by simply adding the value of its individual symbols together. Unlike modern systems, the order of the symbols really don't matter. You can see this example shown in the lower left corner. So based on the picture seen above, our total is 496. And just to remind ourselves, we'll get into higher values, but just reminding us of the values of 1 through 100. 1 is equal to a staff symbol, 10 is equal to a hill bone, and 100 is a coil of rope. So essentially in our example in the farther right corner, we can see that we have 4 of these spirals or these coils. So 4 times 100 will be 400. 9 arches or hill bones times 10 is 90. And 6 lines or staves will be considered the value of 1. So once you add 400 plus 90 plus 6, you get 496.
For this slide, I will give insight to the absence of 0 within the Egyptian numeration system and adapt into how the Hindu Arabic system implements that. The absence of the functional 0 in the ancient Egyptian numeration system is fundamentally due to its additive, non-positional nature. In contrast, the Hindu Arabic system is a place value system where 0 is essential as a placeholder, enabling a compact and efficient representation of numbers and arithmetic.
So I will be talking about converting Egyptian numerals to Hindu Arabic numerals. The Egyptian numeral system is based on symbols for powers of 10 and uses repetition and addition to represent numbers. The Egyptians used a hieroglyphic system for numbers instead of digits. They used symbols to represent values. So a staff equals 1, a heel bone equals 10, a coil of rope is 100, a lotus flower is 1,000, a pointing finger is 10,000, a tadpole is 100,000, and an astonished man with his hands raised up is 1 million.
Are in increments of 5 and 10, I being 1, V being 5, X being 10, L being 50, C being 100, D being 500, and M being 1000. When converting Roman numerals, they are read left to right and their order does matter. A numeral to the right of another should decrease in value, and if it doesn't, there's a subtractive rule within the Roman numeral system. On the other hand, if 2 numerals with the same base, 500 and 100, 50 and 10, or 5 and 1 are next to one another when reading largest to smallest, the numerals with the same base are added together. For example, the Roman numeral MDCLXVI converts to 1666 because D plus C, L plus X, and V plus I.
My topic is multiplication and subtractions with Roman numerals. Roman numerals use letters to represent numbers such as I for 1, V for 5, X for 10, L for 50, and M for 1000. There are some important rules to remember when writing them. If a smaller numeral comes before a larger one, you subtract. Like IV equals 4. If a smaller numeral comes after a larger one, you add. Like VI equals 6. You also can't repeat a numeral more than 3 times in a row, and there is no 0 in Roman numerals. My example problem is IV times M plus LX minus IV. When converted to numbers, that is 4 times 1000 plus 60 minus 4. The answer is 4056, which in Roman numerals is MMMMLVI.